Inside? Good morning, everyone. I hope you all are feeling energized after the breakfast and are ready for day 4 of our workshop. I'm Neha Ghosh. I'm Neha Ghosh, your host, and I'm thrilled to continue this journey with you as we explore more cutting-edge genomic techniques. Today, we have some fascinating sessions lined up. For our first session, we have Dr. Shweta Rajpal and her team of fellows who will walk us through the basics of HGVS nomenclature. This session will explore the practical applications of this crucial system for describing genetic variants.
Good morning, everyone. So, HGVS nomenclature, we will be talking on it now. This is going to be a little dry topic, so we have tried to keep it interactive, and fellows have put lot of memes for you people to have fun in between. So what is in a name? That which we call a rose by any other name would smell as sweet. So this is a famous quote by William Shakespeare. So the naming of Human Genome Variation Society nomenclature, it aims for consistent, unambiguous description of sequence variants, and it is essential for reporting and exchanging information. Why is it important? Suppose I say that I want to visit Punjab. I'm not giving you any specification. Do I want to visit Chandigarh? Do I want to visit Amritsar? Okay, there's no detail in the description. Unless I tell you the detailed address where I want to visit, you won't be able to decipher what exactly I want. But actually I want to visit Lahore in Punjab, because that is also in Punjab. So, just because what strikes you first may not be the correct thing unless I am giving you specification. Similarly, it is very important for you to give a genomic address which is correct. Like in the world, there is country, city, street, and house address. Similarly, in genome, we have address in the form of at chromosome level, genomic level, at which exon, intron, and exact nucleotide position for us to decipher where exactly the change is happening. Okay, so it is very, very important for us to, first of all, tell the specific point where the change is happening, and secondly, it should be uniform across the globe so that everyone calls it the same way. So for the same, there was a group called Sequence Variant Description Working Group that came up for uniform description of the variants. So this comprises of 3 societies, which are Human Genome Variation Society, Human Variome Project, and HUGO, or Human Genome Organization. They worked for uniform description of sequences, and they came up with HGVS nomenclature guidelines. So initially this was published in 2000, and the latest guideline was published in 2016. That was version 20.05. So here they discourage us from using the terms mutation and polymorphism. Why so? Because when we call mutation and polymorphism, like instead of calling these as such, they want us to refer to neutral terms like variant, alteration, and change. So whatever we say, like JAK2V617F mutation, it should be ideally called actually a variant rather than calling mutation, because any variant in itself may not be pathogenic, but it is always in context. Like Dr. Neha was asking for an example the other day that ZRSR2 variant is coming. Should I call it pathogenic, or what should I do? Should I call it variant of uncertain significance? Pathogenicity is one thing, but anything that is there is in context. For example, I would want you people to answer to this scenario where a 80-year-old male being evaluated for erythrocytosis, HGVS revealed DNMT3A R882C. Do we give it importance in this context? Okay. So yes, no, I want you to scan this code and give the answer.
Or you could go to the website and
So this is courtesy Dr. Gaurav. So he comes with these innovative things that, we can do this, we can do that to make it interactive. Google camera, you have to open your camera, scan this, you'll get this thing in Chrome, you go there.
Or you can just go to the menti.com जो website दिख रहा है वहाँ पे जाके join में आप ये code type करो तो भी आ जाए.
Oh, I'll have to start this, no, there in the presentation also. 1 second, sorry. It's coming.
You have answered that question.
हाँ. So I've got 13 answers. Okay. Question is, 80-year-old male with erythrocytosis has DNMT3A R882C. Do you think it is significant? Yes, no. Pathogenic. Anonymous. It is just the proportion that we'll be able to visualize. Don't worry, no one is judging you. Just answer. We won't come to know who has answered what.
Anyway, it looks like a 50-50 division anyway.
Yeah. Okay. Yeah.
Sure.
Say because you have not given transcript ID.
Sorry, what did you want me to do? Go to the previous slide. Yeah. So I guess the answer is 50-50. So as per people who are practicing here, so we would know that this could be age-related clonal hematopoiesis, and we would not really worry that much for this case. But in a patient of AML who has this same mutation along with NPM1, now do we think it is significant? Yes. Okay, now I need to change this slide.
Just like this. And now you can refresh your screen. Should come. The second question should be.
You need to refresh your screen for this to be visible now. Yes, I'm receiving answers now.
Nice. It's working at least.
Yeah. बार बार स्कैन करने की जरूरत नहीं है. सेम थिंग यू कैन रिफ्रेश एंड आंसर क्वेश्चन.
रिफ्रेश द स्क्रीन आ जाएगा. रिफ्रेश नहीं करने से भी आ सकता है. अगर नहीं आए तो जस्ट रिफ्रेश.
So most of the people have answered yes for this, which is the correct thing, because in NPM1 mutated AML, we know that DNMT3A confers poor prognosis. So now, if we look at these variants, this is an example that I have given. So here I have given a screenshot of one of our reports. So can you make out that what is it? This first mutation is JAK2V617F. So we have heard of this, right? Day in, day out, we have read it from the MBBS time, I guess, right? Even before that. So, but why is it such a complicated system? I've told it genomic variant, protein variant, transcript variant. What can we make out? What are these comprising of? So we will be discussing this further. So to name any variant, we need three major portions of it. One is ref-seq ID. The second one is sequence type, where exactly the sequence change is happening. The third is position and what change is happening. So the ref-seq ID and sequence type are separated by a colon, and sequence type and position change is separated by a dot. So here the NMID that we have given is the ref-seq ID. C, that is the coding coordinate, is the sequence type that is there, and position change. So 1849 is the position, and G was the original nucleotide, and T is the one that has been substituted. I mean, the T is the changed nucleotide. There is no space in this syntax. Okay, that is very important. So first we'll deal with the reference sequence. So we had already discussed, when we have to choose reference sequence, we have to go in authentic places and look for what IDs to select. Like permanent identifiers are provided by NCBI and Ensemble, where we can go and choose what RefSeq ID. So these are the screenshot of the websites, Ensemble and NCBI. And it is important to know that in RefSeq, in NCBI provided RefSeq, always there is a version number also, which is also very important. Why this becomes important? Because the version of genome gets updated, and according to the updated version, your nucleotide positions may change. So this becomes very important for you to specify the version number also in the genomic coordinate. Now, there's something called LRG. So what do we mean by LRG? It is locus reference genomic record. So before the presence of main transcript, where there was matching between the Ensemble and NCBI, so HGVS recommended to use LRG, where this was something that was controlling this section. Okay, but since we had this recommendation in 2016, this still is present in the HGVS nomenclature recommendation, where they say that wherever LRG is present, you should use that LRG also, and where there is no LRG available, you should send a request to give LRG as soon as possible for clinically relevant variants. And if there is no LRG, you can use the RefSeq sequence as it is to provide the nomenclature. So we give both. I'll show you. So what is main? So matched annotation from NCBI and Ensemble. So here, whatever transcript are verified by main, we know that they are matched between the two, and we won't have a problem in that. So this was published in 2022, while the HGVS nomenclature, the last update was in 2016. So they still the recommendation is present to give LRG also, but if we have used main select, that problem won't be there, because we have already dealt with that problem where we are using match annotation from NCBI and Ensemble. So the reference sequence that we use, we have to fix this when we are designing the panel and we are ordering the panel, that we are using GRCH 37, 38, what we want to use, and we have to keep that constant. So GRCH 37 and 38 are currently commonly used version, and they were released in Feb 2009 and December 2013, and their UCSC version equivalent are HG19 and HG38. So if we look at RefSeq IDs for different position, we give 3 different coordinate. One is genomic or at chromosomal level, we give at transcript level, and we give at protein level. So we are giving description at all these 3 levels in the reports. So why is it important? Because we are trying to make it uniform, and we want to give it at all levels, where we are giving at chromosomal level, at genomic level, what change has happened. So for chromosomal level, the RefSeq ID has NC in its starting, and at transcript level, at the cDNA level, the RefSeq ID has NM in its starting, and at protein level it has NP. Suppose if you have LRG, you don't need to give this ID, you can say LRG itself, but nowadays, since we are using main select, we can also give this NP, because we have chosen from the main select RefSeq ID. So now if I go to Ensemble website, and suppose I have typed this GATA2 gene, I'm getting these 3 different transcripts that are there, and different amino acid lengths. Which of these would I choose? So now main select and Ensemble canonical has made our life easier, where Ensemble canonical is equivalent to main select, and we can simply choose that. But
yeah, I think maybe you're coming over there.
Yes.
What if Ensemble canonical and main select not match?
Yes. So what happens is that among these 3, whichever has the largest coordinate, we prefer to use that. And other option is that you go to reported literature and see what NMIDs they have used frequently. So then you would be in the same page with them. That is also one option that we would be doing. 3, 4, 2 of them are 480. Yes. Yes, based on literature then.
अगर ये पहला वाला ensemble canonical नहीं होता
Yes.
तो फिर
Again, these days it's best to go to main only and see what
Yes.
is the main transcript. Ideally, one of them will be main. I think the top one is
top one
only
is main.
So then
Top
it's not
one
a
is
problem
main.
at all.
So why are we getting these multiple transcripts? Let's see the concept. So at DNA level, we have the entire genome where we have intergenic region, 3' UTR, we have exons, we have introns, everything. But when it comes to the mRNA level, we have a phenomena called alternate splicing, where all the exon may not be part of different transcripts. So that is why we have different transcript that we may have. Okay, so according to the transcripts, different names are given to them. Similarly, when these undergo translation, they will code for different isoform of proteins. So that is why we have different transcripts that are there in the literature. Now, if we download a sequence from ensemble, suppose I went to this cDNA of ensemble of JAK2 gene in ensemble, and here what I can see, this area is our 3'UTR, and from here ATG starts. So this is my first coding sequence. A is my first coding sequence, and M or methionine is my first amino acid in this JAK2. So this should be 1, and this area is completely the 5'UTR. So if we look at so that is how the coordinates are named. So if I look at the RefSeq ID at the level of genomic, we have NC for JAK2, GATA2 and IKZF1, NP for these things, and NM for same. So this is about RefSeq ID in the report that I had displayed earlier. Now next we go to the sequence type prefix. So what are the different prefixes that we use? Among the commonly used prefixes by us are G, C dot and P dot. So G means the genomic reference sequence. Suppose if you are using circular genomic reference or mitochondrial reference, then you have to use their nomenclature, that is O and M. And if you are using in the non-coding area, you can use N dot. For RNA, you have to use R dot. But these are the commonly used G, C and P. So here in this slide, where is the sequence type prefix? G in this genomic coordinate, P in this protein coordinate, and C in the transcript coordinate or transcript variant. Now we come to the third portion of it, where we are talking about what is the position at which protein change or whatever the nucleotide change is happening, and telling how what has changed to what. So in the third position, we have unique description for preventing confusion. For example, the nucleotide for DNA level, we name it with capital A, G, C, T. But in RNA level, we have to use small letter A, G, C, and we have to use U for obvious reasons. For protein levels, we use 3-letter amino acids and not a single letter in order to avoid confusion, because A has multiple amino acids with which A will be starting with for multiple amino acids. Similarly for G, L, P and T. And for stop codon, wherever stop codon comes, we use either asterisk or the word TER, termination, for termination. Okay. Now, if we have to look for HGVS numbering this thing system, so at the 5'UTR, the coding region will be numbered, will begin from this A codon. So this A will be codon 1. So suppose exon 1 is from 1 to 36, and we have exon 2 from 37 to 96. This is a coding sequence of it. So coding will be C1 to 36 for exon 1, and in between we have 91 nucleotides for intron 1. So how do we give a nomenclature? So we divide 91 by 2, so it would be 45. So basically 1 will be remaining, so that 46th will come towards a plus sign and the remaining will go towards the left sign. So it would be 36. This is a coding sequence, C dot 36 plus 1 to plus 46 here, and 37 would start from here. So 37 -1 to -45 here. Is this clear? Yeah, sure. So exon 1 codes from C1 to 36. So we are just giving name for coding region. So what about the intronic region, how we name them? So exon 2 would be named from 37 to 96. For intronic region, we either have to use plus or minus from the nearest coding sequence. Okay, so now here we have 91 nucleotides in intron 1. This is an odd number. If it was even, it would be plus 45 from here also and minus 45 from here also. That would be from nearest coding sequence. But for odd numbers, we have to use the plus sign. That means till 46 we will be using plus. That is, the 46th position from this will be 36 plus 46. And
So if something is there, maybe the third or fourth position intron.
yes.
So we have to call it from the exon 1, not from the exon 2.
Yes, yes. So if it is here in 4th position here, so it will be 36 plus 4. And 5th, 36 plus 5. But if it is here, it would be 37 minus 4. 4 position from exon 2 would be 37 minus 4.
If it is exactly in the middle,
Exactly, that is what. So if it is even number, the total length, if it is even number, suppose this was 90, then it would be 45 for both the sides. But
we have to go first exon or second exon. 45 minus 1. So sorry.
so even number doesn't matter, right? It is nothing will come in middle. It will be equally divided. But if it is an odd number, the middle part will go to plus. Here, this example I have shown for that only. So
The remaining extra will always be plus.
plus. Always there'll be extra will be 1 only because it is yeah.
Plus side, not to the minus.
Correct.
Just go to that ATG sliders if we have time. Just go back to
Sure.
We'll go very slow on the anyway.
So there's ATG.
This is the 5-UTR. So suppose I have to give a name for this.
5-UTR, not X1, right? So
No. Yes. So exon is from here, ATG.
okay, so do we have every exon starting with ATG?
Yes.
That's the initiation codon, no? Yeah.
So every exon would not start with ATG. Only first exon would start with ATG. Then intronic region will be there. Then exonic region will be there. So only first exon would start with ATG.
That's the point.
Yes.
What were those numbers which were coming?
Yes. So here, so this is first protein position, that is M. So this is our 15th amino acid. Okay, so this is 15. Now this starts from 16 in the next line. And this nucleotide, in one line we get 60 nucleotides. And it forms a frame of 3 nucleotide. So ATG will code for methionine, GGA will code for G. G is what? Glycine. And ATG again methionine. So similarly, like these are the coding region. And this at the genomic level, these are the thing, because this is including, this numbering is including our 5-UTR also. So yeah.
And this genomic coordinates, now this 540, 46 we have written up with the that can go in the forward direction or in the reverse direction.
Yes.
Whereas
the
the
gene.
C is always in the positive.
Yes. So so that we will be discussing. We will be coming to that. Yeah. Now, how do we label the UTR regions? Okay, so because this is a first codon, the UTR will be labeled as C1 -1 to -30 would be for 5-UTR. For example, this is just arbitrary example for understanding purpose. And 3-UTR will be labeled as asterisk 1 to whatever nucleotide number it comes to. Okay. Now, which would you prefer to use G versus C, genomic coordinate versus C? So when we look at genomic it is best best for theoretical purpose, because it is telling you the complete detail where exactly the genomic coordinate change is happening. But you can see that it is very long. It's a very long name, and you may have some difficulty to convey the message that at this position you might not remember. But similarly for coding region, we might remember the protein levels. We almost remember for the common changes that are happening. But practically it is C becomes easier compared to genomic one. But for all practical purposes, for all the reports, we have to give all the 3 coordinates. Yes.
ये जो ये +12 वाला और स्टार वाला है, ये मतलब ये
Yeah.
ये 859 +12 मतलब हम इंट्रोनिक रीजन की बात कर रहे हैं.
Yes.
मतलब ये जिसको फर्स्ट जो 859 जिस एक्सॉन पर है उसके
+12 इंट्रोनिक रीजन पर.
और अगर यही सिमिलरली माइनस साइन होता तो मतलब नेक्स्ट एक्सॉन का हम डिस्क्रिप्शन.
हाँ, तो बेसिकली whatever happens, like 859 should be the ending position of that exon mostly, है ना. But if it was minus sign, it would be beginning position of the next row. तो that
स्टार वाला के मतलब इसका मतलब हम 3' ETR रीजन में
yes 143 position में. हाँ, this is chin. Yes.
एक्सॉनिक रीजन का रेफरेंस ही नहीं दिया.
नहीं.
From the stop codon, it is 143rd position.
Yes. So let's look at different changes. So greater than sign is used for substitution. Okay. So here, for example, we have given 2 examples at coding region and at transcript level. What substitution is happening? C2A and G2C. If this is of same case, again, why would this be different? Yes. So if it is in reverse strand, this again becomes different at the coding and the transcript level. Now underscore sign represents. So we will have examples of that per se. I just because he asked, we'll have proper example of that. So underscore sign indicates a range that is there. So here we can say that at coding region, okay, I'm missing a dot here, sorry, 2506 to 2508, a deletion has happened, is what is shown. Now, parenthesis or the bracket sign is used for uncertainty and predicted consequences. So, for example, you are sequencing the DNA, but you have not done an experimental study. So, for all the protein changes, you have to use parenthesis that is there. So if we use bracket because we have not done in vivo study and proved it that this is the change happening in lab, but this is just based on the DNA sequencing. So we are predicting that because of that nucleotide change, now the protein would be changing from valine to phenylalanine.
Actually, if a variant has happened, we know the coding sequence, then it should correspond to that specific amino acid, right? So why uncertainty?
So uncertainty is that.
No. So the thing is, you have not sequenced the protein. So you have not per se done the protein sequencing and proved it experimentally.
Yes, we do this.
Correct. Everything is in
Every
bracket.
every report will have this
P dot is
parenthesis.
always in bracket.
No, नहीं.
Rate तो
This
यहाँ पे highlight कर
this
दीजिए।
मैंने ये क्या abbreviation use किया वो highlight करके दिखा रही हूँ. No.
No. Rate is just जैसे यहाँ पर range में highlight है, देखो ना,
हाँ, so last slide I have highlighted underscore in red so that I show you which portion what we are using how. That's all.
Just to differentiate from someone who has actually sequenced the protein and experimentally proved, then he or she can put it without brackets. So that is correct.
We need not put in bracket, right?
We have to put in bracket.
Unless you have sequenced it properly. Have you sequenced the protein? Okay, so I know that, but still you have to put in thing because in this case we have not sequenced the protein.
No. What I'm saying is that these sequence is a known thing, and we know what is an exact change, and it should correspond to specific amount.
Correct. But again, in this case it is theoretical. Like, HGVS still makes that distinction whether in your case you have done the protein sequencing and shown it, or you have assumed based on literature. You are absolutely correct. But just that you have to put a bracket to show that I have theoretically deduced it, I have not experimentally proved it.
Yes.
Protein level में
All the report that you put for DNA, you have to put these brackets. So I'll show you the report that we have given. So here, if you see, all the protein changes are in bracket. Okay, so once you put it, usually you will do it practically using some online software tools or so that we'll be discussing, but it will be using bracket there because you have not done that protein level sequencing yourself. Now del indicates deletion. One or more nucleotides are deleted or one or more amino acids are deleted between the start and end of our start and end or stop codon that is there. So here, for example, in this sequence we have these ATC deletion, and that will lead to AGAACA formation. So this will be indicated by this range from what position and to what position deletion is happening at the nucleotide level. At the transcript level, you need not mention the nucleotide exactly what are deleting. You may or may not mention, because HGVS says while you are typing or that, if there is an error, that will give problem. So even if you give a range, that is perfect. So here I have given the genomic coordinate, transcript coordinate, as well as protein coordinate, what is happening with this change. And when you are labeling, the change should be from 5' to 3' direction and not the opposite. So here the coding sequence is from 2506 to 2508 and not the other way round. 2508 to 2506, not this way, 2508 or 2506, and it has to be of 3 nucleotides. So by this you should be able to infer that it is 3 nucleotide. So if we are just saying 2506 to 2506, it doesn't make any sense. It would just be 1 nucleotide deletion, which is not true. So you have to give range from which nucleotide to which nucleotide deletion is happening.
So in the first one, we are having a gap of only 1, right? 378.
No. This is a reference sequence AGAA-ATC-CA. Here ATC is deleted and it is AGAA-CA. This is entirely of the same case. Okay, there are 3 nucleotide deletion that is happening.
37 is the deletion start site.
Yes.
And 39 is the deletion ending site.
So 37, 38, 39. 3 nucleotide have deleted.
Okay, so start and stop, where it starts, deletion starts, and where deletion ends, we have to.
Yes. So 2506, 2507, 2508. 3 nucleotide are getting deleted at coding level. Okay. So now protein level, this is the amino acid that is getting deleted. So 1 amino acid, I have not shown, the same, whatever amino acid is getting deleted, we have to here. So this is kind of in-frame deletion. Here I am just dealing with the variant description. We'll come up with example that how frames are changing and everything, because we have this long session. Here I am just introducing you to the terms, and we will come with discussion of when what changes and how frame will remain same or will it be changing and how we have to deal with it. Inversion. So I don't remember reporting inversion in last 5 years, but this is there in HGVS nomenclature. So probably if we get a case that is there. I mean, inversion 16 and all that in cytogenetics definitely is there, but in DNA level, I don't remember remembering reporting inversion as of now. So inversion, what happens is the nucleotide, there is no substitution, but it just gets inverted at the level, just like inversion 16 at the level it will get inverted. So what you will have is, you will have reverse complement of the original sequence, that in between segment will be reverse complement of the original sequence. So now, yeah. Yes. So here, I want you people to answer to this now. Which of the following nomenclature is correct? aa raha hai kya? Okay. Now this is a question where you have, see, you have deletion in GC. 2 nucleotide have been deleted. So now we can say that this GC is deleted, or we can say that this GC is deleted, or this GC is deleted. Which one do you think is correct?
Okay, top, middle, okay, this one.
देखते.
I will stand like one.
Only participants are answering. Students are not answering. So we have many people. No?
They know already.
You should also answer.
Okay, so we'll see. So we have most of the people have answered top, and some people have answered, and the next majority is bottom, of course. So the correct answer is the last sequence. Why so? Because from 5' to 3', whenever two nucleotides are deleting or any change is happening and resulting in same change, there is a rule called 3' rule, where we presume that 3' is where the change has happened. You know why? So because we can never say hen came first or egg, but just to make the rule clear. And for example, we have 3 years JRs with us. So and we ask that someone has to go and do MPO. Whom do you think who has to go and do first or second or third year? Obvious rule, right? So first year goes and does the staining. So similarly, here just to make it similar in everyone's mind, because no one can say who is correct. Okay, you can't say who people who said the top one are wrong, but just to make the uniform rule and make the uniformity across reporting, this has been made that the 3' change is supposed to be happening.
No, actually, here,
Yeah.
why are they confusing? Because in that initial thing, like we have 3 GCs together, and then 2 are getting deleted. First 2 is all deleted, right? So we can delete from the question, we can delete, right?
So that is what the rule is. The rule is that you have to consider that the last 2 are deleted. Wherever deletion is happening, we don't care. But universally, it is to be believed that
There were 3, now there is 2. So which one has gone? There is no correct answer to this question. Anyone can say 1, second or third has gone.
No, actually, if you consecutively read the nucleotides,
Yes.
numbering, then we will come to know.
So suppose it you read from the reverse strand. So first you will get this one first, no? So it is not like you cannot say that you can be correct or who can be correct. So for uniformity, this rule has been made that let's follow this. Everyone will follow this. That if there is a change, we will consider that 3' has changed. Okay.
जब डेलिंग्स का हम कई बार होता है ना कि
Yes,
behavior
yes.
की वजह उसमें भी हम यही
Yes,
करते
yes,
हैं
yes,
ना,
yes,
मैं
yes, yes.
recall नहीं करती।
Yes, yes, yes.
Keep on happening, then show some example.
Yes, 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 yes.
तो एक बार UK नेकर भी fail हो गया था.
Yes, yes. We had failed in NPM1 mutation that we had detected in but the nomenclature of according to HGVS was not correct. So I have put that example. Purva will be showing us that example. DUP stands for duplication. So what do we mean by duplication? So if a nucleotide has duplicated just in the 3' region, for example, here we have this T that has come and original was T. So basically this is duplication of T that is happening. We can call it insertion also. But when we have same nucleotide in 3' region, same nucleotide or same stretch of nucleotide, we call it duplication. So here we can see TAGA. Here again we have TAGA. So this has to be duplication and not insertion. If it is same nucleotide in 3' region, we have to call it duplication. And again we have to remember that among these which has been duplicated, if we follow the 3' rule, this is the one which is duplicated and not this one. Okay. So there is a prioritization rule in HGVS where we prioritize with substitution, deletion, inversion, then duplication and insertion. That means if you have like same thing, the previous example we could have called insertion also, right? So if it is fitting with duplication, we will give it naming as duplication and not as insertion. So mainly here confusion comes between duplication and insertion only. I don't think other things are much more. What is insertion? If we have, compared to reference sequence, if we have insertion of other nucleotides and we have at least a separation of single nucleotide in between the copy, it should not be immediately 5' copy of the same nucleotide. For example, here we have so how do we name insertion? Will be insertion of the nucleotides that are happening, but they should not be immediately adjacent, like the same nucleotide should not be repeated. That will come to duplication. Okay, so
It is duplication, it is different means it is insertion.
yes, and even if it is same but separated by even a single nucleotide, it will be insertion. Okay. So for insertion, we use the term INS, insertion. For nomenclature of insertion, for protein level, we have a rule. At position, what has changed from what, and what all amino acids have been inserted, from which protein to which protein insertion has happened, that range comes here. And then we have insertion, and it is what all amino acid have been inserted. So this is a kind of in-frame insertion. When we come to examples of these, this will be more clearer to you people. Another thing is frame shift. Suppose your change has happened that is leading to complete change of reading frame. So then you have to use this term FS, or frame shift. So this comes what was there at 123 position. Now what is the change, and frame shift is happening and termination is happening after how many amino acid. So this is the syntax. This will be re-emphasized with example. So don't worry, I'm just introducing you to term and we'll be going slow with examples again. So these are different kind of changes that can happen. You can have substitution, you can have deletion. So this kind of deletion will lead to change of frame. So here 3 nucleotide were coding. Now there is frame change, and now these 3 nucleotide will change because of this deletion. So these 3 nucleotide will now code. And similarly, if insertion happens here, the reading frame will get shifted. What do we mean by delins? So delins is term where there is one or more nucleotide are replaced by a different nucleotide, and there is an insertion also happening, or deletion. So this is combination of deletion and insertion happening, and you have to use the term del ins, and indel is no longer recommended for this. So now if we see, we have seen the ref-seq IDs of these all position. Right. So basically that is for according to HGVS, there is nothing called complex delins. It is supposed to be delins only. But when you have, what happens, because when you are reading in NGS, the variant callers will give you 2 or 3 different mutations that are there, that are happening around the same region. One will be substitution, other one will be insertion, other may be deletion. Usually we get 2 combination that together. And when we look at IGV, what we see is that in the same area we are getting insertion as well as a deletion of a portion, or substitution that will be happening. So once that happens, then we give a search. We label it complex indel or delins that way, but actually according to HGVS it should be just delins, and we will be showing you such example. Yes, we have multiple example of all these scenario. Just now I'm just introducing you to the terms and the syntax. Okay. No. It is delins. Uniformly, it should be delins.
How does delins vary from a substitution? With substitution also you are removing one nucleotide and giving another nucleotide.
Yes.
Then you are also removing.
So, but then delins will have in the same stretch, without an intervening nucleotide, you are having one substitution and other insertion or deletion, whatever is happening. So it is in the same stretch. It is a part of same mutation. So when we show you an example, you will be clearer with that terminology. Yeah. So now if we look at, we had the genomic RefSeq ID here, we had the name, what nucleotide position, and this is the position change that is happening at the genomic level, at the protein level, and this is the transcript level in this report. Okay, so this is how in this report, can you make sense of this report better now? So like this is how, why it has been named so, and so much in detail, so much effort goes in for this, for naming all these, and this has to be named like this only at all the 3 levels that is to be given. Okay. Now, how do we give name to intronic region? So we had discussed this part, but we had discussed that C.100 plus 1. That means from coding region plus 1 will be the next intron to this coding region. But here we have to remember that we cannot just say NMID, because this is not the transcript level, because at transcript level we won't have intron. So we always have to mention the NCID for this. So this is also an important rule of HGVS nomenclature. We may not. If we want to, we may not give the NMID at all. So this is incorrect. Sorry. This. So we may actually I was supposed to give NM. Here I have given NC. So this was supposed to be NC. So I'll just change it. Sorry. That was the wrong slide. So another important rule is that we should follow Hugo nomenclature for all the genes. Like you cannot name some gene according to whatever is there randomly, but you have to follow the HGNC gene symbol approved code for giving the name for genes. So here, if suppose I go and type C-kit, okay, so what it gives me, that the approved symbol is kit, and I cannot use C-kit. You people must have heard C-kit, but that is not the approved symbol. You have to follow Hugo nomenclature. You have to go to this website and type this and get what exactly is the nomenclature for that gene. And gene name has to be in italics. That also is there. So now when we come to the rules, is the reference sequence clearly mentioned? Have we given proper description of the variants? Have we followed the 3- rule? Have we mentioned about the range by using underscore? And have we put the DNA level description, the genomic level, the coding level description, and the predicted change in parentheses? And we should not be using the terms mutation, polymorphism, rather be using variants. Okay. So what are, like, these all nomenclature, if we do it manually, it would be very difficult in day-to-day practices. When we have
तो वहाँ लैंग्वेज जब लिखते हैं ना, देयर इज फ्रेम शिफ्ट म्यूटेशन एंड एक्सॉन 1 ऑफ दिस, तो वहाँ पे फ्रेम शिफ्ट म्यूटेशन की वेरिएंट यूज करो.
And then your reports, it's not in LRG, right? You have to put in LRG.
Because we used to do that, but once the main select came, we stopped using LRG. Like, because we know that we are following that rule, because LRG is for following uniform nomenclature kind of thing, but we know that we are following the rule, so it's okay. We don't need to put LRG in the report that we finalize. Yeah. So if
The reports which we get that ensemble ka reference ID, ENS, so we can use that also.
ensemble, ideally for this thing you should be using NC, NM and NPID. These 3 are must. Suppose if you are getting, that is an additional thing. If you are using, that is not according to HGVS nomenclature rule per se. Yeah. So there are various online tools also that will help you do this.
Always we should go ahead with the checking of alleles also, like if it is in the same chromosome, multiple variants, then if the same allele or different allele.
This would be very difficult to answer for short read sequencing, because if it is point mutation, yes, you could do. So what you can do is you can go to IGV, Integrated Genome Viewer, and what you can see, if it is in the same place, is it coming in different, then you can understand that maybe it is in different allele, and for that you can use that semicolon and you can report that. So, but yeah, that is there, you could do that. Yeah.
So only for SNV and only for distance within a short read.
Yes.
That only you can do. Otherwise.
For larger things, it is not possible at all. So various online platform, the two common online platform that are available for you to do this thing exercises, Mutilizer and Variant Validator. In our lab, we are using Variant Validator, and that is why I had given you people for you to download it and see. Yes. So people who use Mutilizer, they say that they prefer Mutilizer over Variant Validator. So it is just a matter that you get used to one of them and then you are comfortable with that. So since you use Variant Validator before Mutilizer, we think that way. Yeah.
So the original Leiden University guys who were the HGVS came from their thing. Their software is Mutilizer, so they typically use it. But other people usually follow. Correct. But other people, even we feel Variant Validator is easier. Yeah.
Now I would like you people to yes. So let me change the slide. Here. So we have these two options. Here in the left option, in both the option, actually phenylalanine is a protein that is getting deleted. In the left option, it is ATT is forming by this change, while in the right option, ATT is forming by this change. So what do you think? This CTT has got deleted or TCT has got deleted? Which one has got deleted? CTT. Yes. So according to 3' rule, this CTT is the one that has got deleted. So now if we see, so I think 13 people, like most of the people have answered this correctly.
So 18:5 to 1:13, that kind of improvement we see.
Now, can you see, is the syntax that is given below here is correct? This is a very minor change. You have to see it very carefully. Very stupid change, not in the genomic level. Or So that space is not supposed to be there. So this is supposed to be, no, this syntax is incorrect because of the space. G के पहले भी नहीं होना चाहिए ये C के पहले भी नहीं. No, but when it comes to genomic coordinate, no, it comes only, the range comes where the insertion has happened. 2 nucleotide only comes. Even if there is long stretch of insertion, here at genomic level, only 2 nucleotide will be coming. Yeah.
So just similar to deletion, insertion will be interpreted similarly, right? The 23, 24.
In between 23, 24, insertion is happening. Yes.
And for deletion, we include those numbers. Like from
Yes. The complete, yes, because here what we are doing is we are mentioning the nucleotides that have been inserted there. With the help of what you have mentioned, they'll interpret how many number of nucleotides have deleted or which are the nucleotides, because the change is happening, that deletion is happening from compared to the reference genome, right? Here insertion, you don't know any nucleotide may get inserted, right? So here the change has to be mentioned at what all nucleotides have been inserted. And here, when in the genomic name, it comes, it will come where exactly this has happened, 23 to 24, like that. So, okay. What does this equal to symbol mean? Is it nonsense variant, synonymous variant, or insertion? An easy one. Now we see this IVS 15. Which nomenclature is correct for beta HBB gene? IVS 15. Which of the nomenclature is correct? So now you see that we are using NC as well as NM and coding region 92, and in the +5 of that, 5th position of it, we are having change G2C. मैंने वो change नहीं किया होगा फिर.
Thanks for joining कर दिया
अच्छा तो हाँ इतने ही क्वेश्चन थे.
So whenever there's any intronic, you
Hmm.
have to give the genomic plus the interpretation will be made from the codon, like an NMC.
Genomic plus, because you have to give level, all three levels, you will have to give all the three sequence.
You just said कि वो NM नहीं भी दे सकते हैं.
But without NM, we cannot tell you where it is happening. No?
Yes, so that is for practical purpose. Like whenever you are looking at a variant, we are used to think it on in terms of coding region. So that is why it is easier for you. But you can, ideally, you can give only the genomic codon also. But in that case, you have to go then 5 million number आ रहा है जिन chromosome में कहाँ पर है वो ऐसा ढूंढना पड़ेगा. It will be slightly more difficult.
So
मेरा एक silly question.
जैसे
जैसे वेरिएंट वैलिडेटर में 30
So mic off है.
नहीं जरूर सुन लेंगे लोग. वेरिएंट वैलिडेटर में जैसे 2 वर्जन हैं. तो मैंने पुराना वाला यूज किया तो नॉमेनक्लेचर अलग आई, नया वाला किया तो सब कुछ इक्वल टू से एंड हो रहा है. तो वो सारे तो सिनोनिमस नहीं होते.
नहीं, there is some error or glitches sometimes, so that happens in that scenario. ऐसा frequently नहीं होता है. For single variant or is it for everything?
No, for single variant
So-
I've seen at night.
Okay, so for single variant, if you are looking at, no, if it is happening if changes involving the intronic region also, at protein level you will get equal to. If any changes happening at intronic level also, suppose we have an example where we are including the exon and intron, both are getting deleted. Okay, so the change is happening at involving the intronic region also. So then it comes as equal. So then you are not supposed to give that.
We are not supposed to give.
No, it comes as query mark equal. नहीं वो error glitch होगा. It comes as query mark. It doesn't come as हाँ. Yes. We can see, look at that specifically. It should not come that way. So now I would want you people to open your laptop and practice. So I've send you an email. Doctor? अच्छा. हाँ. Doctor.
I've got it.
Oh. So now I would want you people to open the Excel that I had emailed you.
जो क्वेश्चन पूछ रहे उनको माइक लेने के लिए तो ऑनलाइन स्ट्रीमिंग में आवाज नहीं आ रहा, क्या क्वेश्चन पूछ रहे हैं?
We request you people to use mic for questions because people are there on online streaming. They are not able to get the questions.
Here also you need someone, no? Who is there with mic? Neha, you are with the mic. Yeah.
Here.
One more mic and one more volunteer maybe. I think.
4 quadrants.
Yes. 4 quadrant, 4 people.
So I would request all the fellows to distribute the amino acid papers. Also, they'll help you if you have any problems during the steps to follow. So you can ask our fellows. We have Purva, Shadma, Gojri, Saurav, Krishna, Narsimha, Seema. हाँ.
मेरे पास एक
Are we ready with the Excels? We are ready with the Excels. Now I would want you people to open variantvalidator.org. तो उसको फॉरवर्ड कर सकते हैं ना. तो are there any people who have not received email? So I know Shifali has not received email. Anyone else who wants to do and has not received email? Shifali का email address? Shifali का email address बताओ.
Wi-Fi is not working, it seems.
Not working.
B for Bombay. अभी आप प्लीज चले जाओ ना, अभी जाओ लेकिन, क्योंकि मेरा जो स्टूडेंट मतलब बच्ची है वो तो 11 बजे स्कूल से वापस आएगी, तो अभी जा सकते हैं. चिंता नहीं जा रहे हो. 10 बजे जाना है घर. हाँ हाँ, 10:30 पहुँच जाऊँगा. 10:30 से देर. हाँ मैं इसमें व्हाट्सएप और उसको क्या करना है मैं आपको बताता हूँ. आप ऐसी बैग निकाल लो, फिर वहाँ पे जाके कौन सी में डालना है वो सब बताया. थोड़ा सा मतलब वो कल डिस्कस किया था सबने, जो हमारे रूम में है मतलब जो मास्टर बेडरूम में है उसको हम किड्स रूम में डालेंगे. मास्टर बेडरूम वाला इसलिए हम नया मंगा रहे हैं ना, नया जगह. और जो पेरेंट्स रूम में है वो पेरेंट्स रूम में जाएगा, जो हॉल में वो हॉल में जाएगा. किड्स बेडरूम में इसी वजह से जाएगा ना, जो अभी हमारे मास्टर बेडरूम में है वो किड्स बेडरूम में जा रहा है. जो पेरेंट्स रूम में वो पेरेंट्स रूम में रह जाएगा, जो हॉल में है वो हॉल में जाएगा. और जो अभी हमारे नया जगह नया फ्लैट से जो मास्टर बेडरूम है वहाँ पे इसीलिए अभी ऑर्डर किया है मतलब कल डिलीवर. 2 पैनासोनिक के हैं, 1 LG के हैं. चलेगा ना? हाँ हाँ हाँ, वो सब वो गैस वैस अगर भरना पड़ता है क्या होता है वो सब देख लेना प्लीज, वो चला के देख लेना प्लीज. थैंक यू. तो मैं आपको अभी व्हाट्सएप कर दूँ.
It is not working. No, I'm asking the Wi-Fi. People collect it is not working properly is what I understood. But then conversation also is realized that it is not no, but I don't think it will get sorted because the connection is going to be this. So, how many of you are still having problem with internet? Oh, so okay, one hand I could see. Is it connected? Shall we start? We will start and catch up. Is that okay? I don't know her name. Can you ask? PTPN 11 wala. ये है ना सो क्या करना मैंने तो डाला ऐसे कैसे हो गया जो उनको हम बोल देते हैं मैनुअली लिखो
बहुत अच्छी बारिश हो रही है ये उसको देखते देखते प्रैक्टिस करना चाह रहे हैं
You can't have everything in. Yes, so we will go to variantvalidator.org. And there we are going to type this chromosome number 12. So Excel, go to variantvalidator.org. नहीं Excel से ना Excel से please don't take. There was an error I just saw. There it has changed to 13000. So here we can type this manually maybe. So in the this thing coordinate we'll type 12 dash 11 2 888 165 dash 6 G hyphen A. Select GRCH 37. So 37 में हमारे DNA बेस्ड पैनल 37 है, RNA बेस्ड 38 पे. हो गया, देखिए. So choose GRCH 37 and click submit. Then now you will get these NMIDs, 4 NMIDs, and we are not getting anything on main select. So one thing is that we would know that which of PTPN 11 NMID we would have chosen. So did you get this page? Yes. So to know that, we go to ensemble. Yes. So basically, most of the genes you will have tick and cross, and you will have this in main select. But I chose this for an example for people to understand. If you don't have this main select, what do we do? So basically, other examples that you will see will have these ticks. Sometimes they don't have. Some genes don't have this there because it is still getting updated or so like that. So basically, some genes don't have. So I chose an example to deliberately to show this. So if you don't have this, you go to ensemble. So you can open ensemble. Like here, because we don't have main select option, which of these NMIDs would you choose? Go to ensemble. Yeah. Choose the option of using GRCH 37. Click on GRCH 37, go to GRCH 37. Yeah. So basically here you had to choose GRCH 37. So it is updated version, right? 38 is updated version. We have to use the version that we have used for designing the panel. For DNA based panel, we are still using GRCH 37. So it is a human genome version. Yeah. Go to GRCH 37. Type your gene of interest, that is PTPN11. No, Shadma, in the Excel there was a problem, first case, I think. The coordinate, Excel coordinate was problem. So if you are telling her the ये ना, यहाँ से बताना है. Excel से ले रहे हैं. So we could have chosen, instead of all species, we could have chosen human gene, but I let it remain. You will get multiple option where you have to choose the human gene one. And then you get transcripts that are there. Here the one which is ensemble canonical is the one that we have to choose. So we choose this first ID that is there, that is of NM2834.
No, when you go to PTPN 11, before this page, multiple things come up. So we have to always choose the first one, human gene.
Human gene. Now we know that NMID was NM2834. So we go back to variant validator, choose NM2834. Because this was the ensemble canonical, which is yeah, so this won't matter. The version number won't matter. That we'll be mentioning in the report. But we have to have the same NM, the initial portion. Yeah.
How many times do you see such kind of an issue happening? PTPN11 is a very, one is a very common gene.
It's one in maybe 1 in 50 genes or so we do get such problem. Version number won't matter here, because here whatever we will choose, we'll give according to that version number name. So then we get this description. So so I went back to variant validator and chose this NMID 2834 because in ensemble I could see that ensemble canonical is there for 2834. This is the main select ID that is for this NMID. Sure. So now here there are two transcripts that are there. There are two NMIDs, NM2834 and NM80601 here. So among this, the one where ensemble canonical is written, this corresponds to the main select ID. So then we know that we have to use this NMID, NM2834. But ideally speaking, we do this while designing the panel. We have chosen the NMID. When we report, what we do is we see what NMID we have kept for the particular gene, and we use that same NMID. But here, just for a demonstration and just for this thing, I'm showing you this thing. So NM2834 I choose in the variant validator. And I get this transcript level. The genomic level, I'll choose the GRCH37 because we are still using GRCH37. So I'll be copying this code for the coding region. For the transcript region, for the protein region, I'll be choosing the 3 amino acid code one, not the D61N. I'll be choosing the one which has 3 amino acid code. And then this I copy in the report to give all these 3 description. But if you want to do it manually, how do we do it? Let's go to that. How do we go for this particular position in manually? So when we go back and click on this transcript ID, first transcript ID, we would be getting these 3 options on the left side. Exons, cDNA, protein. हाँ, फिर से ensemble में जाना है. Click on the first transcript ID. Then you have to click on this ensemble ID, the first ID. Then 3 options you'll be getting: exon, cDNA, and protein. You have to click on exons. You can right click and ask to open a new tab. Right click and open on new tab. Exon, right click and open in new tab. Because we have to open both exonic coordinates as well as cDNA coordinate. Yeah, and cDNA also you have to open. So you have to open both exonic as well as cDNA. So right click, open. So now if I look at the genomic coordinate that I had provided, the genomic coordinate of PTPN change was happening at 112,888,165 position. And here in exon 3, the position is 112,888,122. This is the starting position, that is 122. So if I have to go to 165, it would be 165 minus 122. So it would be 43, right? So 43. So 43 nucleotide upstream of this. So yes. So we see the change is happening in 112,888,165 here. ये table na, actually I was supposed to send you in Excel. When I have copied na, it has come as 133. So I'm not able to. But in Excel this will be coming to you when you get the VCF files. When you are getting for NGS this thing, you will be getting this thing in your VCF file. From here only we are trying to compare it in Ensemble. Yes, exon and cDNA both में follow करके कहाँ पे क्या change हो रहा है, that will be seen. Exon level पे. So if I want to search from here, it becomes very difficult because I'll have to either count 43 nucleotides from here. So what I'll do is, for an easier format, I go to the cDNA page and I know that this was happening at 61st position, so which is here. So this is 55, 55, 56, 57, 58, 59, 60, 61. So what I could do is I could copy this sequence and search back in the this coordinates. Or at the cDNA coordinate, I would be needing what exactly changes happening in this region. Yes, so cDNA ka page mein, lower down mein, you will be getting, because this change is happening at the 61st position, right? So if you look at the position 55, 56, 57, 58, 59, 60, 61. This is the position D. So if you go to the cDNA page, Achha. So this mutation that is there, this is at D61N, which has come in Excel. It is the Excel will give you these notation, but for ideally giving nomenclature, I am just showing you for demonstration purpose. When we get actually results, it is very easy. We put in variant validator and we just get results. Here I am trying to show what exactly it means. So by doing it manually, it is taking time. Okay. Sure. So, how many of you are with me now? Okay. I'm just trying to see that. Okay. So now, have you come till this part where you have? No. Okay. How many of you have not come till this part where you have clicked on exon and cDNA? Okay. Okay, now if we look at this position where we are seeing the change is happening at 112,888,165. This is a genomic coordinate where PTPN11 change is happening. If we compare it with the exonic sequence, we can see that it is lying in this exon 3 because it is in between 112,888,122 to 112,888,316. Okay, so it is coming in between these. So where exactly it would come? It would be 165 minus 122, which would be 43. So it would come at 43rd nucleotide from here. So but counting this could be difficult. So easier way is that you go to cDNA level and you know that change is happening at the 61st position. So this is 55. So you have this page. You can see that the cDNA coding region 55, 56, 57, 58, 59, 60, 61. D is there. D was the original sequence that was there. Is everyone with me now? Yeah, amino acid. Did I say? Sorry. So then this is where the change is happening at 61 position. So what we can do is we can copy this sequence and नहीं नहीं जो 61 पोजीशन तो आपको एक्सेल में आ जाएगा ना, VCF फाइल में आ जाएगा. हाँ हाँ हाँ, ये मैं आई एम जस्ट डूइंग दिस मैनुअली. अल्टीमेटली यू विल जस्ट बी गेटिंग दिस variant validator thing. I'm just trying to explain you what we are getting in ensemble, so that sometimes if you have to go back, how would you want to go back? This is what. But otherwise you don't need to do this in every case. You'd end every case at this place. But I'm trying to go to ensemble because, you know, in the examples that we'll be showing subsequently, we would be switching to cDNA, we'll be switching to ensemble, then you'll be puzzled that how did this page come, where is this from. So I'm trying to give you hands-on of that by giving you an example. Okay. Now so we have copied a stretch of nucleotide here and we search in the genomic region. So just before this D, this 61 position, I copied this sequence of nucleotide and when I search it, I get it here. So this is the position where G is getting changed to A. So GAC, that was supposed to code for D, is now coding AAC. Okay. Yes, you have to copy and check that. Yes, so basically this D is there, na? This 61st position. Before that, a stretch of nucleotide I copied and I did Control F in the exonic wala page and found where exactly it is coming.
So we can download it.
Yes, in the right side you have the option for download also.
Download sequence. Download the faster format and then proceed.
Yeah, you can do that way also, but it is a tedious thing to do, but to understand the way how to do, that is what.
Now CD mentioned.
Then Gojri. GAC यहाँ पे GAC क्या कौन सा
ये जो GAC है ना, यहाँ तो GAT
नहीं ये वाला GAC ना, दिस इज 61 पोजीशन ना. अच्छा 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 GAT. ओके ओके नहीं 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 एक सेकेंड ना.
61
हाँ हाँ हाँ, तो ये तो फिर ये गलत मैंने वो किया.
ये वाला तो चाहिए.
एक मिनट. तो यहाँ वाला है, तो GAT is changing to
GAT is changing to AAC ना. AAC
रुको रुको
D
तो ये हो गया तुम्हारा दिस इज कोडिंग रीजन में 181 है ना, सो 181 इधर से 163 मतलब 55, 56, 57, 58, 59, 60, 61. So 61. G80 is changing to?
G80 is changing to ये क्या है? D है ना?
नहीं, A to C हो रहा है ना, यहाँ पे तुम्हारा
G to A.
हाँ,
G to A.
PGI पैथोलॉजी,
A80 हो जाएगा. A80.
PGI पैथोलॉजी 12, G80 to G80.
G to A हो गया. C के DNA position.
हाँ, 12 स्मॉल में है ना, 12. Okay, now everyone is with me? Yes. So now here if we want to give a nomenclature, we have to say that at coding region 181, G is changing to A, and this aspartic acid is changing to ASN. So ASN is aspartic acid. D to V, na? Yes. Aspargine, yes. So this is what we have got from variant validator. So I wanted you people to do manually so that when we show examples, you won't be confused at which page we are going to, what we are referring to. So this change we come to know from the Excel that we get. This. In the Excel that I send you, there was an error in this nucleotide that was there. That has become 13000. But I made you people enter this chromosome 12, 112, 888, 165 that way. Yeah. Yes.
And then either we have to go to variant validator, get automatically, or we have to go to ensemble, toggle between exon and releasing and find it how to create an Nomenclature.
Yes. So basically it is very tedious for anyone to do that. It will be time taking and a lot of energy and effort will go. And we have tools available, but there are glitches of tools which we have to know the basic for us to troubleshoot. Now we'll be showing you examples of various mutations that we encounter and how we give nomenclature and how we go both between manually as well as This is just to show you an example for manually, but you just don't need to do that. You can simply put in variant validator and get your variants. Now wherever we will get problems, what we'll do is we will try to go back into this thing and troubleshoot. Why we are showing you this? Because if we are trying to show you an example in a complex case, you will get all the way confused. First, understand how this is happening for a simple case, a simple substitution, and in a forward strand for you to better understand the other examples. So that is why we did that. Yeah. So now I have gang of our enthusiastic fellows who will show you examples. Obviously, I'm there, Gaurav is there, Nikhil sir will be there for explaining you what is happening and why. But they will show you examples of every such scenarios and everything that we have explained by far. So I'll first welcome Dr. Krishna Nair, who is our fellow in the molecular lab, who will be starting with the case 2. I had given example of case 1, that was PTPN 11. Let's go to case 2.
Hello. Thank you, Shweta ma'am. So I'll be mainly covering about point mutation and like how we interpret it on variant validator as well as manually. So starting with, this is the first case, a 60-year-old male complains of fatigue, intense pruritus, worsening on bathing. Lab investigations, HB was increased, hematocrit was raised, bone marrow biopsy revealed a hypercellular marrow with panmyelosis. So could anyone please tell me what diagnosis could we make and what could be the most common mutation we would suspect for this patient? Sorry? Yes. And what could be the most? Yeah, thank you. So similarly, in this case, we had a JAK2 V617F mutation. So it's on chromosome 9 and start and end. And here you can see reference is G, which was altered to T. So we all will be solving these examples later as well. And this is the integrated genomic viewer. Over here, you can see pointer. How do I start the pointer? Thank you. So this is the integrated genomic viewer. Over here we can see at this position we can see that G has okay. So we can see that G has gotten converted to T, and we know that point mutation is when one nucleotide is replaced or substituted by another. And as ma'am has already shown, this is a manual method of doing it. So this is ensemble, this is GRCH37. We put in human species and the JAK2 gene that we're searching for. And this is JAK2 is the forward strand, and over here this is the transcript ID, and it is ensemble canonical, which all have already done. And here we have the exons, cDNA and protein. So what we did was we searched the sequence from the IGV, and we could map our sequence over here on exon 14, and so we know that it's at 617F. So this is the protein, this is the transcript, so this is 616, and we have valine at 617. So we can see that on transcript there's GTC. So we know that in our case G got converted to T, so GTC has gotten converted to TTC, so valine got converted to phenylalanine. So this was the case for JAK2 V617F. Coming to variant validator, as we'll be practicing this as well. So we go to the website, then we'll select the chromosome, start, reference and all sequence. What we have to keep in mind over here is that there has to be no space between them. They have to be replaced by dashes. So here you can see I've replaced it by 3 dashes, and then GRCH37. Sorry. Then we have to use GRCH37 and submit. So over here, as ma'am has already said, we use NMID of main select, match annotation, NCBI and ensemble. And so here is our genomic coordinate, the transcript and protein 3-letter that we use. So our final report is given in this order. And can anyone quickly tell me what are the purple ones that we have marked here? We term it as? Yeah, reference sequence. The green, the G, P and C would be our sequence type, and the maroon would be the position change. And we know we're talking about substitution mutation, so that's replaced by the greater than sign, G to T. Coming to the second case, this is a 63-year-old male, complains of AML with translocation 821. We can see a lot of blast and eosinophils as well. So could anyone tell what could be the most common mutation in an elderly patient which has an adverse prognosis? Yeah, thank you. So similarly, we had KIT D816V. And chromosome 4, here we can see reference was A, which is altered to T. So again, this is the IGV, and we can see at this location, A has gotten converted to T. And so it's 816 when following the protein, this D, and transcript is GAC. So A got converted to T, so GAC got converted to aspargine, got converted, aspartic acid got converted to valine. And And this is the final report. Again, this is the RefSeq ID. This is your sequence type, and this is the position change. So, so we'll have 20 minutes practice sessions. We have already sent the cases to you all, and my seniors and me will help here.
So actually, the Excel now that we have sent you, and we have sent you a PowerPoint also. So you can validate.
It's not the tea break. No.
As people are showing cases, you can match it. That will make it more. So all other examples, if you put the Excel coordinates in variant validator and put the answers in PowerPoint and keep, it will give you more, like, it will make you understand better. You'll be able to appreciate that what is happening in subsequent cases.
Thank you.
First of many, na Sharma.
अरे अभी मीम सेशन स्टार्ट होने वाला है सर. इन लोग का ऐसे कुछ ढूंढने में. And then come back to. तो उसमें जितना टाइम होगा एक्स्ट्रा दिखाना है केसेस क्या करना है, वो जितना टाइम है उसके अकॉर्डिंग वो कर सकते हैं.
Yeah, please.